All right, welcome to College Mathematics MGF1106 Exam 1 Review Version A. So there already is a version B that is available to all of you. If you go into the online math resources page and you click on the College Mathematics, and then you click on Test Review Materials. In here, you can see that there is a version A document, the solution guide, which we're going to be working on right now, and there will be the video that we are recording right now that will be posted. And then right below that, this is a version B. Okay, so after today, there will be two versions of this exam 1 that you can actually look at and practice on and watch the video too. Okay, so your exam 1 test is a total of 20 questions. It goes in order of everything that we learned. Some questions are multiple choice. I believe it's 20. Oh, no, excuse me. 25 questions, not 20. And it goes in order from chapter 2 all the way through chapter 3. Some are multiple choice. Some will be filling in the blanks. Okay? So make sure that you definitely, if it's a fill in the blank one, read that special information on how to write things up. Okay, so in here, you're going to be putting numbers and you're going to separate them by a comma. Okay, so make sure that you pay attention to how you should be writing your answers up. All these questions are just like your homework questions. In fact, these questions are taken directly from the homework. Okay. The only difference between these reviews that are located in our, excuse me, resource Canvas course is that the numbers or the sets have changed, or the truth table statements have changed. That's the only difference. Okay? So let's get started and let's talk about question 1. Let me close some things real quick, because we don't need all that information. So here is question 1. So this is coming straight from 2.1. Okay. Now, as far as this test goes, also, just so you know, there's only one problem where you need a calculator. Other than that, you don't really need to touch a calculator at all through this whole thing. Okay, so it's going to be all about the vocabulary and the symbols and things that you know. Okay, vocabulary is pretty important for us.
Sorry. Do you mean like a regular calculator or a graphing calculator?
A regular calculator will work just fine. All you need to be able to do is add or subtract. That's the only operations you need to be able to do on this.
So calculators are allowed during the exam?
Absolutely. Calculators are allowed. All right. So we want to know, what is the roster form of this set? I was about to spell rooster, and that ain't going to be fun. We want the roster form of the set. And this is why you don't write in pen, because pen is the devil in math. So roster set. What does roster set really mean? What are they after? Oh, and this is very participatory between us, just so you know. What does roster set really mean?
I think it means to like list the
Yeah, list them all out. List the elements that are in this set. Okay, so there are a couple things we need to talk about. What does this symbol mean? There's this capital N, kind of bold like. What does that mean? And anyone can answer. What does this symbol mean? This is only question 1. You guys got this. Give you a hint. These are about a type of number, or the type of numbers that we like. What kind of numbers are these?
Natural numbers.
Say it again.
Natural numbers.
Yes. They are the natural numbers. What are natural numbers?
Like numbers from like 1 through. There's regular numbers.
Yeah.
Like the counting numbers.
Yeah, like the counting numbers. Absolutely. 1, 2, 3, 4, 5, so on and so forth. No decimals, no fractions, no zero, no negatives. Okay. So right here, we want all of the natural numbers that are between 5 and 10. Okay. Will we include 5 in the list? Would 5 be included in the list?
Yes, because it's greater than or equal to.
Because we're equal to, absolutely. Will we include 10 in the list?
Yes, also because it's greater than or equal to.
Because we're equal to, yeah. Anytime you're equal to, you're going to include those numbers. So give me the natural numbers between 5 and 10, and we will include the 5 and the 10. What are they?
5, 6, 7, 8, 9, 10.
You got it. And that is the roster set. So we just go in and you mark B for your answer. Cool beans? I'm going to assume yes. So as I said, that's coming from section 2.1. Okay. So the next question is all about subsets, proper subsets, whether it can be both or neither. So this is coming from 2.2. Okay. And they want you to pick one of these 4 ideas. Now, remember when I talked to you guys in my videos, and hopefully I'm sure your professors have told you if you're in another class, that one of these symbols does not make any sense and will never happen. Which one is it? Which one of these answers can never happen?
D.
Which one?
D.
Say it again. B?
None of the above.
This one?
No, none of the above.
Oh, no. It is possible that none of the above can happen. That is a valid
wow.
answer. We can have that. What else?
The both one?
Nope, we could be both. Proper and a subset. First off, which one of these symbols is a subset? The subset symbol.
A.
Which one of these? That is not the subset symbol. That is the proper subset symbol. So this is the subset symbol. Yeah, this is the proper. All right, so one of these 2 cannot happen ever. Which one is it? We know that these two can happen. It's possible. Which one of these cannot happen on its own? The subset or the proper subset?
The proper subset?
The proper subset. So only proper subsets, you can throw that answer out because it's junk. You cannot be a proper subset only, because one of the rules of being a proper subset is that you are a subset to begin with. If you're not a subset, you can't be proper. Okay? So when you do this question, you only have three options. Only a subset, both, or none. You cannot be proper by itself. It's impossible. Because in order to be proper, you have to be a subset to begin with. Does that make sense?
Yes.
Okay. So now the question is, the set CRM, is it a subset? Is it both? Or is it none of the above according to the set CRMT?
I'd say the subset.
Okay. Why do you say a subset? Talk to me about that.
Because it has some of the same elements of the second one.
You got it. To be a subset, you have to have elements of the main set. And CRM are elements in the CRMT set. So we definitely know it's one of these two. But the question is, what's the difference between being a subset and a proper subset? There was one minor difference. So we know it's one of these two, subset or both. What's the difference between being a subset and a proper subset? What makes a proper subset?
That both sets have the same letters?
No. But you're on the right track if you can tell me a little bit more. What makes a proper subset? Come on, you guys got this. What makes a proper subset?
Is it when they're all the same?
What do you mean all the same?
Like they have the same letters?
So technically these have the same letters.
Yeah, but they wouldn't be because the T isn't there.
Okay, so you're saying that this has to be CRMT and this is CRMT?
Yes.
Okay, so that's what we call equal. Okay, and that's the one thing about proper subsets. Now you have it reversed though. Okay, this is actually going to be both symbols. Let me tell you why. So this is a subset and it is proper. Because in order to be proper, you have to be a subset to begin with, which we already know is happening, and you cannot be equal. To be a proper subset, you have to be a subset to begin with, which we already knew happened, but you cannot be equal. And remember, equals what I just talked about, where and what you were alluding to. Both sets are the same. Set of CRMT, set of CRMT. Those are equal. They would not be proper. But because this is not the same as that one, as in size, it's not equal, it's proper. Does that make sense?
Yeah, makes sense.
Okay.
So,
So to be proper again, you have to be a subset and not equal. Someone had a question. I accidentally cut them off.
I was just going to ask to confirm. So, there has to be one that doesn't have the same amount of elements.
Correct. Not equal.
Okay.
Okay. So if the two sets you're looking at are the exact same sets, it will never be proper. Okay. So they have to be like minus one of the elements or more. Okay. Number 3, and it jumps back into 2.1 again. So they just want to know true or false. What is that E looking symbol between my set notations? What is this symbol right here? What does that mean?
Equal.
Not equal. What does this symbol right here mean? It's like a little phrase. What does that symbol mean?
Is it like a name, like Euler's number, something like that?
Not quite a name. It's like a phrase.
Is it the element?
Yes. This means basically the question that they're asking you is the set 3
An element.
an element of this set?
So it would be true.
True, absolutely. Because this set 3 is right here. See how it matches it 100%.
Mm-hmm.
The set 3. So it is true. Now, just kind of throw a hypothetical. If I did not have the set notation here and I just had the number 3, would this still be true?
Wait, can you repeat that one more time?
Mm-hmm. Pretend like the set notation here is not there and it's just the number 3. Would this still be true?
No, it would be false.
Correct. Because that would just be the number 3. And in here, this is what we call the set 3. It's not the same. Good. All right, moving on. Okay. Question number 4. So it wants us to list all the subsets of A, J, W. All right, so we're going to do this. We want all the subsets of A, J, W. So talk to me. What are they going to be?
A.
Say it again.
A.
Yep. The set A. What else?
Oh, I was talking about the letter A for the answer.
Oh, we'll get to that, but let's write them down real quick.
Okay, J.
So the set J. Next.
W.
Uh-huh. So you've taken care of all the single element sets. What's
Mhm.
next?
AJ.
Okay. Okay.
AW.
All right.
JW.
Perfect. You've taken care of all the 2-element subsets. Anything else? Is that
Then
it?
AWJ.
Okay. So all 3 elements. Is there anything else?
Yeah. WJA.
That's all the same thing here.
Yeah. Okay, done.
You're missing one. There's one more.
AJW. No,
Nope.
I already put that.
We already got the 3 elements. We've got all the 2 elements. We've got all the 1 elements.
So I'm missing one more 3.
You're missing, nope, not a 3.
A1.
Nope, not a 1.
Is it just the outside, like no letters in it?
Oh yeah.
There you go. What's this one called where we don't put anything in it? What's the name of this set? I'll give you a hint. How many elements are in there?
0.
So there's nothing in here. So we call this the empty set because there's nothing there. So these are all of our subsets. There are a total of 1, 2, 3, 4, 5, 6, 7, 8. So we just got to make sure that we select the answer. So you guys, you said A, and A would have been wrong because you're missing which one in A? What's
Empty.
missing from A? Yeah, you're missing the empty. So I need one that has 8. Okay, so if you counted this up, 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7. Nope. 1, 2, 3, 4, 5, 6, 7, 8. That's got to be it. And if you look at this, it contains all the ones we've written down. So the answer is C.
C.
Does that make sense?
Yes.
Okay. So there's number 4. And that one came from 2.2. Now we're going to jump into number 5, which jumps into 2.3. We're getting into sets now. And this is where you learned about in 2.3 unions, intersections, complements, the universe. Okay? So we've got the following information. The universe is the sets 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A is 1, 2, 3, 4. Set B is 1, 2, 7. Okay? So when I talked about this with you guys, I encouraged you to make a Venn diagram because that's going to help you answer your questions. Okay? And again, we know that the universe is set 1, 2, 3, 4, 5, 6, 7, 8, 9. Set A was, and I've forgotten, 1, 2, 3, 4. And set B is 1, 2, 7. So when we start making a Venn diagram, where do we start? Where do we start when we start to make a Venn diagram?
Like the middle Points?
In the middle.
A and B.
Uh-huh. So this wants to know exactly what's in both A and B. So what do these two share?
1 and 2.
Okay. And then once you use those, they're done. You're never going to touch them again. Okay? Then you start to work your way out. So what numbers are left in A?
Um, 3 and 4.
Uh-huh. And those numbers are now gone. What numbers left in B?
7.
Okay. And those numbers are now gone. Is there anybody in the universe?
Well, yeah, there's
5, 6, 8, and 9.
Yes. 5, 6, 8, and 9. And now we can answer the question. Even though I know we could have answered it before, but I like to review Venn diagrams because they get a lot more complicated, and I always like to approach it from a Venn diagram standpoint. So our question is A, this symbol B. What does this symbol mean?
intersection.
Intersection. And what do we look at in the intersection?
What kind of numbers intersect? What's the
Where they
numbers?
overlap, right?
Overlapping, yeah.
Yeah. What's in common? So what are the numbers that A and B both have in common when they overlap?
1 and 2.
Mm-hmm. And see with the Venn diagram, it's very visual to see that. And there's your answer. So when you go to your exam, you'll click A and you'll put 1, 2 in the blank. All right, moving on. Number 6 is still from 2.3, but we're getting a little bit more complicated. So our universe is A, F, H, N, Q, T, W, Z. Our set A is A, W, Z. Our set B is F, W, Z. All right. A, B, universe. So, just like before, start in the middle. Is there anything in the middle of A and B?
W.
Anything else?
Z.
Z, yeah.
Z. Yeah. It's got W and Z. So we cross those off. Anything left in A?
A.
Mm-hmm. Cross those
And
off. Anything left in B?
F.
Yep. Anything in the universe?
H and Q T.
Yep. H, N, Q, T. All right. So now we are ready to start to answer this question. So this is where, Mr. Armstrong came up with like an order of operations. So I like to share those. Armstrong's order of operations for sets. So My order of operations, there are three pieces. Start with the parentheses, then you deal with the complement, and then you deal with unions / intersections. So, do I have parentheses up here?
Yes.
So then we're going to work inside our parentheses first. Inside the parenthesis, do I have any complements? Inside.
W and Z, I think.
No, complements. Do you see any complements inside the parenthesis?
No.
No. So then that means we're going to deal with the union and intersection. So what is the symbol in here?
Intersection.
Intersection. So we want to know what is A intersect B. And I believe you just gave me that answer a second ago. So what is A intersect B?
WZ.
WZ. Okay. And that right there takes care of my parenthesis. And now we start over, but now we're on the outside. Okay, we're going to look at the whole thing. On the outside here, do I have any complements?
Yeah, you have the B complements.
The B complements. What is complement after? What does compliment mean for us? And it's not, no, oh, you look lovely today. Not that kind of compliment. What is a compliment?
Is it like a negative or something?
Not quite.
Oh,
Or does anybody know what the complement of B is? Let's just take it from there. What is the complement of B? Okay, well, let's start with the complement then. All right, complement in my video that I talked with you guys about, and whenever I teach it, I relate it to a Thanos snap. Because when Thanos snapped his fingers, stuff went away. So a complement means that we're going to snap the B circle out of existence. So the entire B circle is gone. That's what a complement means. Snap it out of existence. So what do you have left?
A,
Keep going.
Q, T, H, and N.
You got it. All that is left. All of that is B complement. A, H, N, Q, T. Does that make sense?
Yes.
All right, so now we're at the last piece. We took care of the complement. Now we're back to unions and intersections. And so now we want the union of these two sets, which we have down here. What does union want? So we're taking the union of these two sets, which are right here. What does union mean for us?
Like all of them?
Yes, all of them. Anybody in these sets, you're coming to the party. Okay? So give me all of them. So give me everybody that is listed.
WZ,
Okay?
AH, NQ, and T.
That's it. That's the answer. So really, it's everybody that we had in the universe except for F. That's the only letter that did not get put into this answer. A, H, N, Q, T, W, Z. We didn't put in the F. That was it. So when you come back over here, you select A, and then you put in A, comma, H, comma, N, comma, Q, comma, T, comma, W, comma, Z. And that's the answer. All right. Number 7, they have been nice enough to provide us the Venn diagram, still in section 2.3. A, U, parenthesis, A, U, B, parenthesis, complement. All right. So, do we have parentheses? Going
Yes.
through my order of operations. All right. So inside the parenthesis, inside it, do we have a complement? So in here, no, because that complement right there is on the outside. So do we have a union or intersection?
Yes.
Which one do we have? Is this a union or an intersection?
Union.
All right. And union says, as what you guys told me, give me everybody. So give me the union of A and B based off of our picture.
2, 5,
Mm-hmm.
7, 11, 13, 17, and 21.
You got it. So the union of A and B was 2, 5, 7, 11, 13, 17, 21. That was everybody that was in those two circles. All right. So we've done the parentheses. Now we work on the outside. So outside, do I have a complement?
Yes.
And who are we taking the complement of?
Is it from a union or from the parentheses? Yeah, a
Exactly.
union.
So we're taking this set right here and we're snapping it out of existence. So all these numbers right here, the 2, 5, 7, 11, 13, 17, 21, are now gone. What's left?
The ones outside.
Which are?
24, 27, 34, I think that is. 37 and 49.
Perfecto. I love it. So here's what our set looks like now. The complement of the union we just had is 24, 27, 34, 37, 49. Okay. Now, right here, we need to know what set A is before we can take care of the next union. So we've taken care of the complement, but we do need to know what set A is. So if we go back real quick and look, who all is in set A?
2, 5, 7, 11.
Is that it?
And 13 and 17.
And 13 and 17 because they are inside the circle A. So all these numbers are in A. Okay, so now we have everything that we need. We don't need that picture anymore. So we now can do the whole thing because we know what this set is. It's right there. We know what set A is. It's right there. So I need the union between these two sets. Tell me what it is. What is the union between these two sets?
Well, the two sets don't really have any numbers in common, do they?
Well, but we're not asking for in common. What does union want?
Just
Bring
put
them all
two-
together.
all together?
Just give them to me all.
Mhm.
So what's the union then?
2, 5, 7,
Yep.
11,
Yep.
13,
Yep.
17,
Yep.
24,
Yep.
27, 34, 37, and 49.
So good. Yeah. Union says, give me everybody. And that is everybody in those sets. Now, although I like what you said, if this was the intersection, nothing would have been in common then, right?
Mhm.
So if that was really an intersection, what would we have put in here?
Would it be like an empty set or something?
Yeah, technically it should have had this if it was an intersection, but it's not. So there's actually answers in here. But it would have been the empty set if it was an intersection for this problem. Absolutely. But we had answers. So in this space, you would click in it, you would be putting 2, 5, 7, 11, 13, 17, 24, 27, 34, 37, 49. So that's all the numbers that would go in there. So basically, you're listing all the numbers up here, but 21. Lowly 21 didn't get to go. All right, number 8 jumps us into 2.4. The only difference between 2.3 and 2.4 is I add another circle. Okay? So we're basically doing the same thing again, but this time we have 3 circles that we're going to be looking at. Give me just a moment to get this written down. And we're going to make a 3-circle Venn diagram. B, C, 2, 3, 5, 6, 7, 9. A is equal to 5. B equals 1, 2, and 3. C equals 4, 5. Okay. So when I make a 3-circle Venn diagram, I start by making my first 2 circles. And then I go right in the middle of their intersection and I draw a circle downward. And this is A, B, C, union. Or sorry, not union, universe. So again, when we have 3 circles, where do we start?
In the middle.
In the middle. Nothing changes. So in the middle, I want what all 3 of these A, B's, and C's have in common.
1,
Okay. Anything else?
2,
2.
3.
Anything else? And 3. So cross off the 1, 2s, and 3s. They're all gone. Can't use them again. So now, this is all about what do A and B have in common. Anything?
No.
No. So you move on. This is about what B and C have in common. Anything?
5. Wait.
B and
Oh,
C.
No.
None.
No. A and C.
5.
Okay. So we put 5 in here. Cross off the 5s. Okay. Anything left in A?
7,
No.
8.
No, not A. There's nothing left in A. Anything left in B?
No.
Anything left in C?
4.
So we put the 4 in here, cross off the 4s. Now, anything out in the universe?
6, 7, 8, and 9.
There we go. Now we know where everything goes. let's answer our question. So do we have parentheses?
Yes.
Yes. So we start inside there. Inside my parenthesis, do I have any, oh gosh, compliments? The word was slipping my mind. Do I have any compliments?
Yes.
But that's outside.
Oh
What
yeah,
about,
no, not inside.
okay, not inside. So then we take care of the union. So we need to know what is A union B. What is A union B?
1,
Okay,
2,
okay,
and 3.
okay. One more.
4?
Nope.
No, 5. 5.
5. A union B means that you look at the circles A and B and you give me everybody. Yes, I know 5 is also in C, but isn't 5 in A?
Yes.
So it counts. So A union B. Okay. Now, do I have any, are we done inside? Do I got any compliments on the outside?
Yes.
So we're going to Thanos snap A union B. So it's now like these two circles are gone. They no longer exist. What's left?
4, 6, 7, 8, and 9.
Perfect. That's what a complement does. Snaps them out of existence. Okay? And we need to know what C is real quick. What is our C set?
1, 2, 3, 4, 5.
Mm-hmm. And now we're ready to answer intersection. So we're ready to do the whole thing. Because we have our two sets here. We have the complement set and we have the C set. Now, what does intersection want? What is an intersection about? Come on, you got this. What's an intersection about?
What A and C had in common?
What they have in common. So what do those two sets have in common?
1,
Nope.
2.
Nope.
Wait, you said A and C?
Between these two sets, the union and the C,
I'd say 4.
they only have 4. That's the answer. Sorry if I said A and C. Didn't mean to confuse you. Between our two sets, the complement and the C, the only thing they have in common is the 4. So we come back in here and you select A and you put in the number 4. Okay. So number 9, 2.3. They kind of went easy on us. They actually gave us a Venn diagram, and all we have to do is figure out what is A union B. And if you notice, it says give it to us in ascending order. And all the answers I have been writing have been in ascending order, just so you know. So make sure that you watch that. So ascending means from lowest to highest. So give me A union B.
6 and 12?
It's a little bit more than that. Union means everybody. It means
everything.
everybody in both of those sets.
Everything. Okay.
1, 3, 4,
Okay. 1, 3, 4,
7, 8, 10,
7.
11, 12,
Oh, you skipped one. So 1, 3,
6,
4,
7, 8.
6, 7, 8. Sorry, I got to fix that because I'm writing this down as we go.
1, 3, 4, 6, 7, 8, 10, 11, 12, 13.
Hold on, I had to do some quick. Okay, you said 1, 3, 4, 6, 7, 8. What else?
10, 11, 12, 13.
Yes, that's the answer. Because those are all the numbers that are in the circle A and the circle B. There you go. Good job. So you would come in here, you would select, well, actually you wouldn't have to select anything, you just type it in there. So you put the 1, comma, the 3, comma, the 4, comma, 6, comma, 7, comma, 8, comma, 10, comma, 11, comma, 12, comma, 13, comma, or no comma after 13, sorry. All right, number 10. Again, they give us another Venn diagram. And they want us to do A intersect B intersect C. So what do you think the intersection of all three circles, what numbers go in there?
Everything in A and B and C.
That is not everything. This is not a union. This is an intersection.
Everything they have in common.
Everything they have in common. So what do all three of them have in common?
6, 21, 17,
Nope.
11, 13.
6 is not in common on all three of them. 6 is only in common
21?
on A and B. 21. There you go. That's all that was asking for. What do all three of these have in common? What number or numbers? And in our case, it's just one. You're going to put 21 in here. This is what all three have in common. Cool beans?
Yep.
All right. So number 11 will be the last Venn diagram we deal with. This is the one you need a calculator for. This is the calculator problem. And all you got to do is be able to add and subtract. And notice that you have 6 questions to answer. And hopefully this problem looks familiar because we did something like this in the video. You had one like this in your homework. I think there was one like this on your quiz. Okay. So it says a survey of 113 college students was taken to determine the musical styles they liked. Of those, 39 students listened to rock, 27 listened to classical, and 33 listened to jazz. Also, 17 students listened to rock and jazz, 14 listened to rock and classical, and 8 to classical and jazz. Finally, 5 students listened to all 3 musical styles. Construct the Venn diagram and determine the cardinalities. So each one of these answers is a number, okay? How do I start this word problem? Where do we begin? Well, actually, first, when I make my Venn diagram, how many circles am I going to have?
3.
3. What's one of my circles going to be called?
A.
We can call it A, or let's give it a more specific name according to what we're dealing with. Instead of A, let's call it
Rock.
Rock. There we go. I want to rock. All right. What's another circle we're going to call? What's another circle?
I'm guessing the other two would be called classical and jazz.
You got it. There we go. So we have a Venn diagram that looks like this. Rock, classical, jazz. And then out here, this is the universe. Okay. So where do we start on our Venn diagram?
Middle.
Right in the middle. Okay. So somewhere in here, they told us that middle number. And as I told you guys before, this is the only number you can trust. What is the middle number? How many students are in all three?
5.
5. Because when you do this, you start from the bottom and we're going to work our way backwards. This is the only number you can accept. Every number from here on out is going to be manipulated and changed. Okay? So we have 5 in the middle, and now we're going to start to work our way out. So what is this section right here about? Who are we dealing with in here?
So, what R and C have in common?
So RNC, what does RNC stand for?
Rock and classical.
Okay.
So we find the students that listen to
So
both and put the number in there.
you got, well, sort of. So we're looking for rock and classical. How many students listen to rock and classical?
You need to subtract that number by 5.
Yes. So there are 14 students total that listen to rock and classical. Okay. But we've already taken care of 5 of those students. So we're not going to put 14 in that spot. We're going to put, man, I wish I could highlight it, but it's not letting me. We're going to put whatever 14 minus 5 is, because that 14 is made up of this entire section. So what is 14 minus 5?
9.
That's how many listen to just rock and classical. Because if I take 9 plus 5, I get the 14. All right. Sorry, let me go back to that. What section is this about?
Sorry, I had to get something. And what was the question again?
What section is this about?
3? I mean, is the answer 3?
Well, I don't know. We're going to find out. But who are we dealing with here?
The students who like to listen to classical and jazz. And you guys subtract
Classical
5.
and jazz. Uh-huh. So if we go back, here are the students that do classical and jazz. There are 8 of those. Okay. So 5 minus 8, or 8 minus 5. And you said 3, which is exactly correct, because 5 plus 3 is 8. Okay. What students are we concerned with here?
The students that listen to rock and jazz.
Rock and jazz. So that's 17 students. Okay. So 17 minus 5 gives us
17. 12.
12. And now we continue working our way out. Okay. So what students are we concerned with right here?
The students listen to rock, but you gotta
Okay.
subtract it by 9, 12, and 5.
You got it. So we're going to find the students that listen to rock, but we got to subtract that number by 12, 5, and 9 because we've already taken care of them. So if we come back out here, 39 students listen to rock. But we need to go to our calculator and take 39 minus 12 minus 5 minus 9. How many students listen to rock? It says this circle should be 39 total. So how many students are out here?
Is it 13?
It is 13.
Right.
Okay. And moving on. Now we're going to talk about classical. So up here it says 27 listen to classical. So this entire circle C is made up of 27, but we got to subtract the 9, the 5, and the 3 to get how many are just classical.
Is the answer 10?
It is 10. And now we're going to look at the jazz. We're going to see how many listen to jazz, and we're going to subtract the 12, the 5, and the 3 from it. So out here, it says 33 listen to jazz. So how many are right in here?
Is that 13?
It is 13 again. Now, the question is there anybody in the universe? So you see how we've been going backwards through this problem. There's one more number left. This right here is how many students we talked to. But we've already taken care of some of them in the circle. So we've already taken care of this many. So you need to take 113 minus the 13, minus the 9, minus the 10, minus the 5, minus the 12, minus the 3, minus the 13. You need to take all of these numbers that we have in here, all 7 of them, and subtract them from 13, and that will tell you, or 113, and that will tell you if there's anybody in the universe, because not everybody listens to rock, classical, and jazz. So is there anyone in the universe?
Is it 48?
It is 48. Now that the Venn diagram is done, we can start tackling the questions. Okay, that was the math part. There's all the math that's on your exam. So we've got 6 questions. So part A says, how many are only rock? So I'm going to write these down real quick. Part B is about how many are classical and jazz, not rock. Then it's pretty much the same question. The only difference is instead of the and, it is or.
So wait, are you asking for question A or question B?
I'm writing these down real quick.
Oh, okay.
So question D is all about exactly one style. Part E is exactly 2 styles. And C is none. Okay. Now that I've gotten these written down, let's start answering some questions. So how many listen to only rock based off of our Venn diagram?
13?
13. So I'm going to kind of code this. So this 13 right there are the ones that are only rock. 13, 13. Okay. Now, this next one. What does the word and symbolize for us in a Venn diagram? It represents one of those symbols that we were using earlier. Is it union, intersection, or complement? What is and really about? Union, intersection, or complement?
Union?
It is not a union. Try again. Is it intersection or complement?
Complement?
Nope, not a complement
Is
either.
intersection?
It is an intersection.
Okay.
So what this is talking about is this wants the intersection of classical and jazz. Not represents one of our symbols. Is it, sorry, I put the union symbol there. I should have been intersection. Not represents one of our symbols. Is it the union or the complement? Which symbol do you think not is?
So, wait, what was the question again?
So not, like and, represents one of our symbols. We know and is intersection, so that means does the not represent union or complement? Which symbol is that in disguise?
Complement?
It is the complement. So we're going to look at the intersection between classical and jazz, and you're going to snap anyone with rock out of the picture. That's what this is saying. Okay? So first off, what numbers represent the intersection between classical and jazz? Which numbers are the intersection between classical and jazz?
3, 5, and 3 and 5?
Just 3 and 5. These two. Yeah. But here you got to do one extra piece. Any of these numbers that contain rock, gone. So do any of these numbers disappear?
5?
The 5 will, because it contains rock. So what's the answer? How many students listen to classical and jazz but no rock?
3?
3. It's that one right there.
Mm-hmm.
Okay. Now, down here, or represents one of our symbols. And since you know that this is intersection and this is complement, that means the or is the union. So you're going to look at the union between classical and jazz, and then we're going to snap the rock out.
Okay.
So what numbers up here represent the union between classical and jazz?
So the union would just be everything that's in both of them except for rock?
Well, we'll get to the except for rock part. Just tell me about the union. Give me the union between...
Everything that's in both of them?
Uh-huh. So who is that?
So 13, 10, 3, 5, 12, 9.
And 9. There you go. So these numbers right in here. 10, 9, 5, 3, 12, 13. Now, snap. Any number with rock is gone. What do we got left?
13, 3, and 10.
13, 3, and 10. So you add all those up, and what do you get?
26.
Okay. So you take the 13, the 3, and the 10, add that all up, and you get 26. Perfect.
Okay.
All right. The next question says, exactly one style. What numbers deal with exactly one style of music?
13, 10, and 13.
Yep. That's one style. It's pure jazz. That's one style. It's purely classical. That's one style. It's purely rock. So if I take 13, 10, and 13 and add that together, what do we get?
36.
You got it. Two styles. What numbers deal with two styles?
12, 9, and 3.
12, 9, and 3. Perfect. So
I
squiggles.
was thinking it's a bit like a color wheel, you know, like you got like your primary colors, you got your tertiary colors. And 12, 9, 3 would be, for instance, kind of like tertiary colors.
Yep. So if we take 12, 9, and 3, add those up, how much should we get?
24.
Okay. And last but not least, how many listen to none of them?
48.
That's the 48. And there you go. It's going to be very important that you get your Venn diagram right. Otherwise, these numbers are going to be off. Okay, so make sure that you're really, really careful on that. I need one more shape. Make it a pentagon. So there we go. All right. And that ends chapter 2. Time to move on to chapter 3. So everything from question 12 on is chapter 3. Truth tables and logic. All right. So number 12. It says, express the following statement in an equivalent way for part A. So it wants to know which one is equivalent. For part B, it says, write the negation of the following statement. Okay, so these were kind of a pain. And when I talked about them in class, you know, I gave you the notes that had all the information in order to write this. Okay. And so I'll show you what that chart looked like. There were 2 of them. And so this was the one chart right here that helped you write the equivalent. Okay. So here was the statement and here's an equivalent form. And remember that it works both forwards and backwards. Okay. So we have a statement that says, not all students are bored. So part A wants the equivalent statement. All right, so let me flip back to this. Our statement says not all students are born. Not all students are bored. In here on this chart, one of these matches that form. Which one of these matches the not all students all are bored? The first, the second, the third, or the fourth line?
Would it be at least one student is bored?
Nope, don't try to tell me the answer yet. Okay. I need you to find me which one these match. Is it line 1, line 2, line 3, or line 4? Not all students are bored.
So 4?
It's down here. So this is the statement they gave us. Not all students are bored. So the equivalent one will be right here. So you see how that's different from what you just told me. So this is the statement we need to make. Not all students are bored. So the equivalent statement will be some students are not bored. Okay? That's the equivalent statement for this. So you're going to go in there to the multiple choice and you're going to find some students are not bored. So, and that statement is right there at the top. It has to be that statement. Yeah, our book and everything, and it's very picky. So this is one of those questions you just got to be really, really careful on. So part B says, I now need the negation of that statement. So there was another chart that looks like this. I can't get everything on my screen. I was hoping. So we've got this statement and its negation, and we've got this statement and its negation. But you have two statements we can work with right now. We have not all students are bored, and we also know that we have some students are not bored. We can use either one of these. But we're looking for one of these type of statements in this table. So not all students are bored, or some students are not bored. Do we see any of those in here in line 1 or line 2? Not all students are bored, or look for some students are not bored. Line 1 or line 2, where do we have that sentence? Not all students are bored. Or you can find the sentence, some students are not bored. Line 1 or line 2 has the statement. Which one? Not all students are bored. Or look for the statement, some students are not bored. Where is that statement in here? Line 1 or line 2?
Sorry, could you repeat the question again?
So we've got two statements we can look for. Not all students are bored. Do you see that anywhere in here between these two or these two? Not all students are bored.
The second one
Do you
is
see that?
Second one, maybe?
Nope.
Okay.
Nope. It's got to match. Not all students are bored. Do you see that anywhere in here?
Some
Has to
A.
match. Nope. It's not some. It says not all students. So I need something that says not all. Do you see that in here?
No.
Then we're going to look at the second sentence, the equivalent one we found. Do you see a sentence in here that says some students are not bored?
Well, I see the negation for the first one is some A or not B.
There you go. You found it. So this is the statement we have. So this is the negation of it. It works forwards and backwards.
Okay.
So this is the statement we have. That's the negation. So the negation is then all students are bored. So that would be the answer you're looking for. All students are bored. So if we come out here, there it is. All students are bored. You've got to match it word for word. That's the problem with this one. This question is you got to make sure that you know the wording. Okay? Let's move on past that one. That was in section 3.1, just so you know. And those two charts, if you wanted to look at them again, let me give you those. So 3.1, page 121 in our textbook has the equivalent expressions, and page 122 has the negations. All right, let's move past that. That question's a pain anyway. So, and here they're telling you that you've got a statement P that says the chair is broken. And we got a statement Q that says I study. And they want us to take the following sentence, the chair is broken, or I study.
I think I know the answer.
You think you know the answer? All right, well, let's talk about it.
I think it's the PVQ. Well, it's not actually a V, but it's like a V-looking thing.
Yeah. That's right. So when we talked about this, remember I kind of gave you ways to kind of do like notation and annotate this stuff. So this is the first sentence, which matches the P that you told me. The chair is broken. The chair is broken is P. I always circle the conjunctions. So I circle the or, and as you said, the or looks like a V. And I study is the second statement, and that's Q. And so there's that answer you just gave me. Perfect. P, V, Q. Now, please know that when you do this, make sure that you are using their symbols. Okay? So do not use a capital V in here. You need to use their symbol for or.
Yeah.
And it will be in that, it should be in the math pop-up tools, the My Math Lab pop-up tools, right below the blank when you click on it. So
Yeah, I made that mistake before and I realized, oh no.
yeah. Make sure you use their symbols. Okay? So be careful of that. So the next one, number 14. And that was coming from 3.2. And number 14 is also coming from 3.2. So number 14 tells us that P is 3 plus 9 equal to 11. And Q is 3 times 6 equals 18. They want to know the truth value for negate P, V, negate Q. Oh man, I meant to say squiggles so I can have you tell me that it's a negation symbol. So the squiggle line there is negation. The V we already know is or. And they want to know, is it true or false? Now, right away, you know whether P is true. Is 3 plus 9 equal to 11? Is 3 plus 9 equal to 11? Is that true or false? Is 3 plus 9 equal to 11?
No.
No. So this is a false statement for P. Is 3 times 6 equal to 18?
No.
It's not. 3 times 6?
Oh, sorry. 3 times 6. I thought you said plus.
No.
Yes, that is correct. 3 times 6 is 18.
So you know these. Now we got to answer this question. So we know that this is a false statement. We know that this is a true statement. So remember that Mr. Armstrong had his own order of operations to this as well too. Order of operations for truth tables. When we do our order of operations, the first thing you're going to work with is parentheses. Then you will take care of negations. Then you will take care of ands and ors. Then you will take care of conditionals. And last but not least, you will take care of biconditionals. So obviously we have no parentheses. Do we have negations? Do we have squiggles?
Yes.
Yes. So we're going to take care of the squiggle P first. What do negations do to truth values?
They make them false and
Not necessarily false, they make them their opposite.
the opposites. So
Okay.
a false value would be true and a true value would be false.
All right. So P was false. So the negation P would be
True.
true. So we use the P column to help us answer this one. So this is now true. So we took care of this one. We also need to take care of the negate Q.
It
So
would be false.
this would be false because our original Q value was true. All right. So we've taken care of negations. Now we're going to move on. Do we have ands and ors? Absolutely. We have an or. So now we're going to answer the whole statement. Which two columns are going to help me answer the or? Which two columns do I need to look at?
So the second two?
Yeah, the ones we just made.
Yeah, those ones.
The negate P and the negate Q will help us answer this. Now, ors are only what when what? Ors are only true when what happens, or is it ors are only false when what happens? What can you tell me about ors?
I think I heard that they're only false when both of things are false. If one of
You
the
got
things is
it.
true, then the whole thing's true.
All right. So ors are only false when both are false. We have true, false. So what's the
So it's
value?
true.
There you go. So in the end, the truth value for this is that it is true. So we go out here and we're going to select true. That's what they were after. In the end, this statement is true. All right, moving on. Number 15, doing a complete truth table. Doing a complete truth table. So give me a moment to write this down. We've got P and Q. And we know that it goes true, true, false, false, true, false, true, false. And they want us to figure out what is the negation of P and then do negate P or Q. And they want all 8 of those answers. And they will be drop-down menus on your exam. So you don't actually have to type in the T or F. It's a drop-down menu. All right. So what does a negation do?
Make something the opposite
All right.
value.
So we're going to use the P column here to help us answer the negation. So true becomes?
False.
Okay. True becomes?
False.
False becomes?
True.
False becomes?
True.
Okay. So now you know all the answers for the negate P column. All right. Now ors. Ors are only what when what?
Ors are only false when both the values are false.
And which two columns are we going to use?
The first and the second two?
The second two. These two. Yeah, the first one is done. So we're going to use the Q column and the negate P column to help us out. So I've got true, false.
So it's true and false, I guess.
True, false is what? According to the OR.
True.
True. Because it's only false when both are false. False, false.
False.
True, true.
True.
False, true.
True.
There you go. There's all the answers for the last column. And that's what they're looking there. That's what they're looking for, those 8 answers. I would do it on paper first and then go and then put in all the information you need. Okay. Moving to number 16. So number 16, they give us a sentence. You did not do the laundry, and you left the room a mess. So the first thing we need to do is turn this into symbols for part A and then select the correct one. A, B, C, or D. So let's turn this into symbols. What's the first statement that we have here? What should we underline? What's our statement?
You didn't do the laundry, you left him a mess.
Too much. What's the first sentence we have? Because there are technically 2 sentences in here. What's the first one?
The ones that you just wrote down?
So I've got this sentence, but there are technically 2 statements in here, 2 sentences. What's the first one?
You did not clean your room? I mean, you didn't do the laundry?
There we go. That's the first statement. So what are we going to call that?
P?
That's your P. But also notice there's the word not in here. What does not represent?
Negation?
So this is negate P. Oh, there's an and. What's the symbol for and?
The up looking thing?
The up looking thing, the rooftop. That's what I call it.
I don't really know the actual name for it.
Or you can call it a tent. All right, it's just like an upside down V. We just call it and.
Okay.
All right. Then we have a second statement. What would you call this?
You left the room a mess.
Okay, so what is that symbol wise?
Q.
That's Q. So now you know what our statement consists of. Negate P and Q. So if we go back, there are two answers that have those symbols. Which ones? Negate P and Q.
The first one.
The first one and
The second one.
the second one. Now we have to look at these things very carefully. A says that the statement P is you did not do the laundry.
Okay.
B says the statement P is you did the laundry. So let's talk about that. So it wants to know what is the original P statement. So this statement right here represents negate P. Does that make sense?
Mm-hmm. So the
You
original statement-
did, say it again.
I'm saying so the original statement would be negate P and Q.
No. The original P statement, what would the original P statement be to this negation? How do I take it back to just P, not negate P?
You did the laundry.
You did the laundry. So when I go back here, would I select A or B?
So to write it,
Which one would you select,
B?
A or B? You would select B because this is the one that has that statement you just told me to write down. The original P statement is you did the laundry. In our problem, they gave you the conjugate. Sorry, not conjugate. The negation of the P. So you got to make sure that you're careful on that. Okay? Make sure that you read your choices carefully. So the answer is B, because that's the one that has all this information. The original P is you did the laundry. The original Q is you left the room a mess. And those are the symbols that we have from the statement that they gave us.
okay.
Now, part B says truth table this bad boy. So
All right.
P, Q, true, true, false, false, true, false, true, false. And in this truth table, it is also a drop-down menu. So you either drop down and select true, or you drop down and select false.
Okay. So for the first question, I'm guessing I put false because it's negated.
Okay. So we're going to negate the P first, right?
Mhm.
So we're going to use the P column to help us out. So you said put what here?
false.
Yep. Then
False.
yep. Next.
True.
Perfect. Next.
And then true.
Yay. Now over here it says we're going to negate P and Q. Ands are only what when what. So ors are only false when both are false. Ands are only what when what.
And you're only true when they're both true.
Yes. Ands are only true when they're both true. Which two columns am I going to look at?
Well, I'd say the first column. I think
Not
the first
P.
column.
No.
Yeah. So we're looking at second two.
We're looking at which two?
Second two columns, the Q and the negative.
You got it. These are telling you exactly which two columns to look at. We need the negate P and we need the Q. All right.
Mhm.
So you said ands are only true when both are true. So true,
So
false.
False.
Okay. False, false.
False.
True, true.
True.
False, true.
S-
So now you have all 8 of those answers.
mhm.
Okay. And then there's a part C.
All right.
So part C says, when we look at the truth table, indicate one of the conditions that makes the statement true. Okay. So we're going to come back here. This is the column you're looking at. It wants to know what is the condition to be true. Where is it that we were true in here? Was this one
Right.
true?
Well, the only instance where the thing is true is when the P is false and the Q is true.
There you go. P is false and Q is true. So we need to find one of our multiple choice statements that says that.
Mhm.
So we come in. It says the statement is true for all conditions. That's not true. The statement is true when P is true and Q is false. Nope, that wasn't it. There are no conditions. That's not true because we know there is one.
So the answer is D.
The answer is D because it says it's true when P is false, Q is true. And that's exactly what you just told me. There you go. That's number 16.
All right.
All right. Number 17.
Hmm.
17 is coming from 3-2 as well. All this has been in 3-2. We haven't left that one yet.
Mhm.
So we got P and parenthesis Q or R. And out to the side, it is telling us that the P, the Q, and the R, it's telling us their truth values. So it says P is false, Q is true, R is true. So we want to find the truth value in the end. In the end, when we do this, is it true or false? All right. So the first thing is going through my order of operations. Do you have parentheses?
Mhm.
Yes. We have parentheses right here. So inside my parentheses, are there any negations?
No.
No. Do we have and or an or?
We have or.
Okay. So we're going to work or first. What 2 columns will I use for my or?
The second two.
Yep. So ors are only what when what?
Totally false when both are false.
So I got true, true.
That's true.
All right. So we finished with the parenthesis. Now we're going to move to the outside. So on the outside, do I have any negations?
Nope.
Do I have any ands or ors?
We have an and.
Okay. So we're going to do P and parenthesis Q, V, R. All right. What 2 columns am I going to look at for this?
The first and the last.
You got it. The first one and the last column we just made.
Mhm.
So ands are only what when what?
And are only true when the whole thing is true. And since the P is
You got-
false, then the whole thing's false, I guess.
You got it. Not a guess. You know for sure. So the answer is false. That's what you're going to select.
Okay.
Moving on. So answer is false. So you would select the second. Number 18. We're almost there. Almost near the end. So number 18, we're definitely jumping into 3.3 now. So we're going to do a truth table, negate P, and parenthesis, P arrow Q, parenthesis. So PT. Now this truth table is one where you will actually be filling in the true and the false. And
Okay.
same thing on 19.
It's kind of interesting how if some of the problems you just click on the button, others you have to fill it in.
Yep. All depends upon what they want to throw at you.
So I'm guessing the first thing would be the P is false, it's negated.
Yeah, we'll get to that just a second. I'm trying to get this written down real quick so I can switch to my document camera for us. Almost got it. All right, here we go. So we're going to use the first column to help us out. And so tell me, what are our answers going down?
So the first answer would be false.
Keep going.
The second one, so P to Q would be true.
Whoa, not P to Q. Just keep going down this column.
Oh,
Keep negating.
oops. Not sure why I did that. So the second one would be also false.
Okay,
And the next two would be true.
you got it. So false, false, true, true.
All right.
All right. So now, what does this arrow mean?
Then, I think.
Yeah, it means if then. It's a conditional statement. And with conditionals, you have to be very, very careful because you have to look at them in a certain order.
Mhm.
So the way that you look at your values from one to the next is very important. So conditionals, you have a thing called the antecedent and the consequent.
Mhm.
We're looking at these two columns to help us out. Which one is the antecedent, P or Q?
I'm guessing it's P.
You got it. So I'm going to put ant by it. And that means Q is the consequent. So I'm going to put con by it. And you need to look at these columns from the antecedent to the consequent because conditionals are only false when what happens?
They're only false if the one of them's false.
If
they're
what?
only false. They're only false if both are both false.
Nope.
They're only false if the Q is false.
And the P has to be
True?
true. But I don't like using P and Q. It's better to say the antecedent and the consequent. So this is only going to be false if the antecedent is true and the consequent is false.
Okay.
Conditionals are only false when the antecedent is true and the consequent is false. This is why you need to look at the order very, very carefully. So true to true gets us what?
True?
True to false gets us what?
False.
That's the false one. False to true?
True?
False to false.
True?
Yep. This is only false when the antecedent is true and the consequent is false.
Okay.
All right. So now that we got that done, over here we're going to do an and. Which two columns are we going to look at for the and?
The third one and the fourth one.
Yep, indeedies. And ands are only what when what?
And are only true if they're both true.
Okay. So, false, true.
False.
False, false.
False.
True, true.
True.
True, true.
True.
There you go. You just got to go in and put in your letters.
Okay.
Number 19, another truth table. Yay, what fun. So a little bit longer.
Okay.
Again, this is coming from 3.4.
Okay. So the first one is an and
Okay.
they're both
Hold on 1 second.
sorry.
It's okay. Now, this is one where I think the exam does you a disservice because I think it's missing some information that's pretty important. Okay. So this is why I always talk about my order of operations, because it's trying to skip a step. And sometimes that's a lot to try and keep in your mind. So I think it's missing 2 columns before we do the negate P and negate Q column and the P or Q column. And then last, we'll do the whole thing. I think you're missing 2 columns. What do you think my 2 columns are about? What do you think would be pretty important for us to know?
P and Q.
We got P and Q, but it's something about those.
The negated P and Q.
Yes. I think they did us a disservice by keeping those out. So I'm going to squeeze them back in. This is why I do stuff by hand first before I even work on what's going on in there. So let's talk about negate P. Which column are you going to look at?
The first one.
The first one. So what do we get in our column?
False. False. And next to it, true.
Mm-hmm. And then we'll
Q.
use Q.
And for Q, it's false.
Okay.
True.
Uh-huh.
False.
Perfect.
True.
Perfect. See, I think these 2 columns are important because now we'll hit up the 2 columns they wanted us to hit up first. So now you can actually see what you're working with instead of trying to keep it all straight in your mind.
Okay.
So that's why I added those 2 columns in, even though they weren't there. So we'll use our negation columns, and ands are only what when what?
And you're only true when they're both true.
All right, so false, false.
Is false.
False, true.
Is false false.
False, or true, false.
Is false.
True, true.
True.
Okay. See, that would have been a lot. I mean, like, even for me, I probably could have gotten through it in my head, but it's so much easier if I can just see it
Okay.
to help me out. All right. So now we've got P, V, Q. So that's P or Q. So we're going to jump back. We're going to use our P and Q column again.
Mm-hmm.
So ors are only what when what?
Ors are only false if they're both false.
All right. So true, true.
Is true.
True, false.
Is true.
False, true.
Is true.
False, false.
Is false.
Okay. And these are answers that you're going to need. So I'll box those in. And now we're on that last column.
All right.
So we'll use the two columns we just made to help us out. So again, it's another and. And you know that ands are only true when both are true.
Mhm.
So false, true.
Would be false.
False, true.
Also false.
False, true.
False.
True, false.
False.
Okay. So there's all the answers. That's your first part. And now they got a follow-up question where it says, based on our outcomes, is this a tautology, a self-contradiction, or neither? What's a tautology mean?
I don't quite remember.
Well, what do you think it means? A tautology. What do you think has to happen in the very end?
Has to be all true.
Yeah, that's what tautology means. It's all true. Is that what happened to us?
No.
No. So what do you think a self-contradiction means?
It's all false.
You got it. Is that what happened to us?
Yep.
Then it's a self-contradiction. If it wasn't any of those two, select neither.
All right.
So tautology means all true. Self-contradiction means all false.
Okay.
All right. So the next one wants to know, are these two statements equivalent? Are these two statements equivalent? So in order to do that, the easiest thing to do, set up a truth table. So we've got P, negate P, conditional negate Q, and we've got Q, conditional P.
I'd say just by looking at them that they're the exact opposites of each other.
Well, but that doesn't mean that they're necessarily equivalent. Equivalent means that they have the same truth values in the same order in the end.
Okay.
So we know that a truth table, you got P and Q, and it always goes true, true, false, false, true, false, true, false. Okay. So let's start with this statement. What do we need to figure out first?
The first one?
Okay, so we're looking at the first statement, the negate P, conditional negate Q. What do we got to figure out first?
You can figure out their values.
Of what first?
Negative P.
Yeah, we're going to negate the P. Then what would you also do?
Negative Q.
Negate Q. And
then-
now you could figure out the
Then-
conditional.
Negate P. The arrow thing in negate Q.
There you go. All right, so let's do this real quick. So we're going to negate the P. So we'll take
All
the
right.
P.
So it's false. False. True. True.
Perfect. All right, then we'll take the Q column, negate it.
Q would be false. True. False. True.
Okay. Now, this is a conditional, so order matters.
Mhm.
Using these two columns right here, the negate P, the negate Q, who's the antecedent?
True. I mean,
Which one is
first
the
one's
antecedent?
the negate P is antecedent and the negate Q is the consequent.
You got it. All right. So we'll use these two columns to help us answer the next piece. So false to true, or false to false gets us?
True.
True.
because
False
don't-
to true gets us.
true,
Mm-hmm. True to false gets us.
false,
And true to true gets us.
true.
Okay. So these things are going to be equivalent if this ends up with the same truth value sequence.
All right.
The moment it messes up, it's not equivalent.
Okay.
Okay?
Mhm.
All right. So we're looking at this new statement now. So we're going to compare these two columns.
Mhm.
We got a conditional. Who is the antecedent and who is the consequent?
So I'd say that Q is the antecedent and P is the consequence.
Q is the antecedent, P is the consequent. Yep. So be careful at how you look at this. So you're going to be looking at it backwards. Okay. So this is coming from, just so you know, this is coming from section 3.5. So true to true.
Would be true.
True to true would be true. You got it. False to true.
Would also be true.
Say it again.
Also true.
Yes. True to false.
Is false.
There's your false one. And false to false.
False is true.
Okay. Do these two columns match 100%?
Mhm. Yep.
Then they are equivalent. Cool beans? All right. Number 21, only 5 more. All right. So this one is all about the different biconditionals that you can write. Okay. This one is coming from 3.5 as well. I think it was 3.5. Yeah. Yep. 3.5. So it says, oh, so appropriate. If goblins come out to play, then it is not Halloween. And so this is what we call the conditional statement because it's an if then. And this is what we call P arrow Q. And now what they want us to do down below is give us the different versions of this. And one version is what we call the converse. Do you remember what the converse is
It's
in terms of symbols?
Is it switching the order around?
You got it. So converse is Q arrow P. So switch the order around.
So it'd
If
be,
what?
if it is not Halloween, the goblins must play.
You got it. If it is not Halloween, then goblins come out to play. Or the goblins come out to play. It's all the same. The next one they want you to write is what we call the inverse.
This is where you switch the values.
What do you mean values?
I guess you make it the opposite of the value that it was previously. Like for instance,
Okay. Careful about saying value. You just negate
just negate it, yeah.
the P and the Q. Take the conditional and negate it. All right, so give me the inverse of if goblins come out to play, then it is not Halloween.
If goblins do not come out to play, then it's Halloween.
There you go. So if goblins do not come out to play, or you can say don't come out to play, then it is Halloween, because you unnegate the negation that was there. Perfect.
Okay. And I'm guessing the contrapositive is where you switch the order and also negate it.
You got it.
Would be
That's the idea. So
if
hold
it is-
on, number 21.
so it would be if it is Halloween, then the goblins do not come. The goblins. Wait, no. If it is Halloween, then the goblins do not come out to play.
You got it. If it is Halloween, then goblins do not or don't come out to play. There you go. So those are the statements that they're looking for. So we just come back to our exam. So the first one, the converse, you told me, if it is not Halloween, then the goblins come out to play. So that was D. Then in the next one, the inverse would be if it is not, oh, sorry. Goblins, or sorry, if goblins do not come out to play, then it is Halloween. No.
No, I think it is. Yeah. C.
Yeah. Sorry. Yeah. That's right. I'm mixing my statements up. If goblins do not come out to play, then it is Halloween. So it is C. Yep. And then the last one, the contrapositive. If it is Halloween, then goblins do not come out to play.
Yeah.
So C again. And there we are. Number 22. So number 22 is coming from 3.6. 3.6. And they want to know what is or they want you to perform De Morgan's law on this and give us the equivalent statement. It's not the case that she makes the bed or I make the bed. Okay. All right, so let's write this up in symbols. So in my videos and when I talk in class, I tell you that this piece right here, it is not the case that is a large negation word. So this symbol right there really means negate parenthesis. So this is like a large negation symbol. Then we've got she makes the bed. So what do you want to call that? What
Well,
symbol should we give? She makes the bed. Nope.
Negations, I guess, just Q or P or something.
Pick one.
P.
P is very good. We always start with P. So that's P. Oh, I see or. So what do we put in there?
The V looking
The
thing?
V. And then I make the bed. So that is
Q.
Q.
And then you
So
put
there's
the-
what we're looking at. So De Morgan's it's kind of, and I use this very loosely when I say this, it's kind of like distributive property. And it's going to distribute through this parenthesis and change everything. So this P becomes a
negative P.
negate P. What does the negation do to an or?
Well, I don't-
Turns it into an
Okay.
and. It
Switch
just flips
I
it.
guess.
Ors become ands. If it was an and, it would have turned into an or.
Okay.
And then negation would go to the Q and make that negate Q.
Okay.
So that is the statement we have to write. This is what we're after.
Okay.
So we need to negate P. Well, you told me that P is she makes the bed. Give me the negation. She.
She does not make the bed.
There you go. Does not make the bed. What's this symbol?
And
negate Q. Q was I make the bed.
so I do not make the bed.
There you go. That's the sentence we're looking for. She does not make the bed, and I do not make the bed.
Right.
So we come back in here. If, nope, doesn't start with an if. She does not make the bed, or, okay, it's not that one. That says or. She makes the bed. Nope, that's not right. She does not make the bed, and I do not make the bed. There it is.
Mhm.
So the answer is D. And that's number 22. That one was coming from 3.6. So 3.7 is for number 23 and 24. And then 3.8 is number 25. So this one wants us to know about the argument, okay? So it says, your mom said it was okay. Or you can sleep over. Next sentence says, this weekend you can't sleep over. The conclusion, that's what those three dots mean. Therefore, this weekend, your mom said it was okay. All right, so the first thing, right down below, if you read, it says P represents this weekend your mom says okay. Q represents you can sleep over. So let's turn this into symbols because we need those symbols. It's going to help us out. So it said, your mom said it was okay. What is that?
P.
I see an or. So what is that?
V.
You can sleep over. So what is that?
Thank you.
Okay. You got it. Now we move to the next one. It says, this weekend you can't sleep over.
So that be negate Q.
So what is that? You got it because you got that not right there. So this is a negate Q. And then down here it says, this weekend your mom said it was okay.
So that would be
Your mom says it's okay. Who is that?
P.
So this is P. So this is what we now know symbolic wise of our situation.
So P, V, Q, then on top of that there's a Q, and there's like a line, and then there's a 3 dots in and a P.
You got it. So that's what we got. Okay. So there's a couple ways that you can do this depending on what your professor does. So in our book, on page 190, there is a list of reasonings that we already know. These top ones are valid. These bottom ones are the invalid ones. So one thing you could do, depending on if your professor lets you have this or not, you could take these symbols and see if I can get these both on the same screen. Nope, it ain't gonna happen. Actually, I can do this. There we go. And see if you can find the argument according to what we have written. See if this is anywhere up here, and that will tell you if it's valid or invalid. If it's not on this chart, then we need to do a truth table.
I can see it in disjunctive reasoning.
In
too.
disjunctive. So right there.
Yes.
Absolutely. This all matches exactly what we have here. So is this valid or invalid then?
Apparently it's valid.
It is valid. So you will select the valid answer. And then once you have selected the valid answer, you need to write what we had written vertically in symbols horizontally. Okay? So you would come down here and select B. And then now we're going to write this in symbols. So when we write this in symbols, it will start with a bracket. And then what comes next?
P.
I agree. P what?
V, Q.
And this has to be in parentheses.
Yes, in parentheses.
Then what comes?
And then outside the parentheses, you'll have a negate Q.
Nope.
Oh,
There'll
no.
be something there, but then we will have negate Q, yes.
Oh, the arrow thing. The if then.
Nope, not yet. It's an and.
And.
An and goes outside that. Because what you're doing is you're listing each one of these with an and between them.
Okay.
So we listed the first one, and we have this, and then now you're going to close your brackets. So we've listed all this. Now what happens? What symbol do we need?
The if then symbol.
The biconditional, because my 3 dots turn into that.
Therefore,
And then what?
P.
P. Now, so you know, it's technically not wrong if you actually put parentheses around this, okay?
Mm-hmm.
But I will tell you, in the My Math Lab, it will count you wrong if you put parentheses around this. Because My Math Lab has this rule that if it's just a single statement, like this is just one statement, you don't need parentheses. These were 2 statements. It's made up of P and Q. So that's why there are parentheses here. That's why this one didn't get parentheses either. It's just P. So single statements do not get parentheses.
Okay.
So if you put a parenthesis around that, it's going to count you wrong, just so you know.
But the brackets are okay?
The brackets out here are a must, yes. And that's what it looks like symbolically. And if you don't have the table that I just showed you, then this is what you run a truth table on. And the brackets are just like parentheses. They don't change anything. So you would run a truth table on this if you didn't have the table I just showed you. All right, number 24. Pretty much the same process again. So number 24, they give us the sentence, having a college degree is necessary for obtaining a scientific position. You have a college degree. So you have a scientific position.
Well, before we start the all the stuff, I can already tell this argument probably isn't valid because, I mean, just because you have a college degree doesn't mean you have a scientific position.
Okay, that is true.
My mom has
And
a-
you are going to be correct. In the end, this is going to be invalid. But before we can get to that part, we have
you
to
have to
write
figure
the
out the
symbols.
translation. Yeah.
Yeah, you got to translate it.
hmm
So let's talk about that real quick. So right here, we need to be careful of this. The is necessary for. Do you know what symbol that is?
No.
It's a conditional symbol.
Oh, okay. So if
Now, the other thing about this is because it doesn't say if then, you got to make sure that you understand that when you have this wording is necessary for, this thing has been written backwards. This part right here is actually the consequent. This part right here is the antecedent.
okay.
Okay? So whenever you have the words is necessary for, this thing is written backwards.
Mhm.
So with that in mind, having a college degree, what letter would you give that?
Q.
Exactly. And that's what they do. Because Q is usually the second letter. And this is the technically the second statement. Does that make sense?
Mhm.
Obtaining a scientific position is the first sentence. So we're going to give it what letter?
P.
P. So this thing is really written P arrow Q.
Okay.
But these two sentences, the real P is obtaining the scientific position. The real Q is the college degree. So be careful with that. It's written backwards. So the next sentence says, you have a college degree. Who is that?
Q.
Q. The so is the same thing as a therefore.
The 3 dots.
So this is the 3 dots. And then last, we conclude you have a scientific position. Who is that?
P.
P. So there's what it looks like symbolic wise.
Okay.
P arrow Q, Q, therefore P. And if we go and look, which one is that?
D? No, not D, not D.
Not D.
B.
It is
B.
B. And then last but not least, you already know that it is invalid. And again, we could look this up on the chart. Because on the chart, on page 190, show you real quick, it is in the invalid category. Because what it is trying to do is this right here, the fallacy of the converse. If P, then Q, Q, conclude P. Invalid. And again, you could run a truth table on it. If you wanted to, you would be running the truth table on these symbols. Bracket, parenthesis P, arrow Q, parenthesis, and Q, close the bracket, conditional sign again, P. So if you wanted to run a truth table, that's what you would run the truth table on. Again, the brackets, if you can just think of those as parentheses when you're running the truth table. Same. Okay. Last problem, and we're done. Number 25 is coming from section 3.8. It is an Euler diagram, but I call the guy Euler because that's what his name looks like anyway. But it is pronounced Euler. So Euler says all silverware are dishwasher safe. And then no candles are dishwasher safe. And we conclude, therefore, no candles are silverware. Well, God, I hope so.
I feel like it's probably technically correct because, I mean, I guess no candles are silverware.
True. But let's make a picture to verify.
But we should also, verify it and stuff.
That's what Euler diagrams are all about. You're going to make a lovely picture of the situation.
So, I guess it would be like two circles because they might intersect. With silverware.
Yep. All right, hold on one second. We're going to get to that. You're so fast. All right. So first we're going to graph the first one. So it says all silverware are dishwasher safe. Okay. So that's going to be two circles. And because it's all, that means one circle will be inside the other.
Oh,
Okay. So all silverware are dishwasher safe. So that means I'm going to call this middle circle S for silverware. And I'm going to call my big circle around it dishwasher safe. So DS. Okay. So, and this makes sense because all my silverware are dishwasher safe. They're inside my dishwasher circle. Can't exist anywhere else. Okay. Now the question is, we have this other circle we have to draw. We have no candles are dishwasher safe. So that means there's a third circle, candles. Can that third circle exist anywhere inside my dishwasher circle?
no.
No. So I have a third circle that's out here in space. We'll call it C for candles. Because this cannot exist anywhere in there. So this is what the picture looks like. There's no other interpretation. If there were, we would draw them. But there's no other place for me to put the candle circle. It cannot be anywhere inside here or touching the dishwasher circle.
Mm-hmm.
So the question is, when we go down here, it says no candles are silverware. So what this is asking then is it wants to make sure that in your picture, Are the candles and silverware touching?
Nope.
Nope. So then it is valid because it is 100% true for my picture. And that is exam 1. If we didn't talk about it, it ain't on there.
All right. That was very informative.
Thanks.